Here are further examples of applying the chain rule. Y equals tangent of 1 over x. So again, step one is just figuring out if this is the composition of two functions, what function is on the outside, what function is on the inside. Here it's relatively straightforward to see that f of x is tan x, and what we're plugging into that is 1 over x, or x to the negative 1. Derivative of tan x, as we found out a few videos ago, is secant squared of x. Whereas the derivative of x to the negative 1, we use the power rule, negative 1 times x to the negative 2, or in other words, negative 1 over x squared. So now that we found the derivatives of the individual functions, we're ready to apply the chain rule. Y prime equals f prime of ordinary g of x times g prime of x. So this would be secant squared of 1 over x times derivative of g, which is negative 1 over x squared. So typically we would write the polynomial and the rational function out in front. Negative 1 over x squared times secant squared of 1 over x. So now, number 4, y equals secant x. Well, in what sense is this a composition? Well, keep in mind, we don't know how to take the derivative of secant, but we know that secant is 1 over cosine x. And when we write it in this form, it's clear that we do, in fact, have a composite function. The outside function, f of x, is 1 over x. The inside function is cosine x. And it's the composition of these two functions that makes the secant function. So the derivative of 1 over x, as we found above, I'll just jump to the answer here, it's negative 1 over x squared. Derivative of cosine x is negative sine x. And so that means y prime, which is f prime of g of x, times g prime of x. F prime of g of x, this is going to be negative 1 over g squared. So negative 1 over cosine squared times derivative of g, which is negative sine x. So the negatives cancel, and what I have is sine x over cosine squared x. I'm going to write this as sine x over cosine x times 1 over cosine x. And of course, sine over cosine, that is just tangent, and 1 over cosine is secant. So the derivative of secant x is tangent x times secant x. And I will leave it to the viewer as an exercise to verify the same is true for the cofunctions, that the derivative of the cosecant is negative cotangent x cosecant x.